All right then. So let's go. Again, more voices is better. Um, I don't know how long this will take. It's really, I'm gonna kind of play off of your vibe. If I get the sense that you're feeling it, then we can probably go a bit quicker. But it's got to be like a whole classy thing. So, um, number one, yeah, it's gonna have to stop. Thanks, bud. Is it a function? Does anyone not know why it's a function? Because it's okay to say I don't know. Yep. Does everyone understand the vertical line test? Good. Okay, then we can just, on every problem when you get to your packet today, you'll just write like yes or no. You could write something like sí, señor, or está bien, or no, or not a function, or no way, Jose, or something. I don't care what you write as long as somehow you're conveying the idea that it is or is not a function. Okay. That's all. Now we're going to get to the hard part, the domain and the range. So in question one, and I'm going to keep using my same words that I used yesterday. The domain is not a hard thing once you're ready. Here it goes. How far left does graphy go? Forever to the left. So I will write negative infinity. And why is it negative infinity? Because it's going to the negative side. It's not because it's going down. Up and down mean nothing with domain. Domain is all about left and right. That arrow is not going down to me. It's going left right now. Later on, it'll go down. But this graph goes forever to the left. That's why I say negative infinity. How far to the right does graphy go? To positive infinity. And that is your domain done. And remember that with any sort of infinity, we always round our brackets, right? Let's talk range. I changed my thinking now and I give zero hoots about left and right. My question now is how far low does graphy go? He goes forever downwards. He's now a downwards arrow. How far up does graphy go? Any questions about that? Okay, let's head to question two. So this is like our warm-up questions. Is this a function? No, you agree? Yeah, it fails the vertical line test pretty bad. So let's talk about domain and range. Domain, when I ask you for the domain, you need a little translator in your head that when I say domain, you think, how far left does graphy go? So the question is, how far left does graphy go? What's the answer? Forever, right? And when kids look at this and they go, well, it only makes it to like -8. I'm like, do you not see? And honestly, it might be hard for you to see it up on my TV, but there's an arrow there. So it goes forever to the left because it's going to the left. Do you view that arrow as going up? Don't. It is currently not about whether it's going up or down. Domain is only a consideration of left or right. If we were talking about range, then I would look at this as an upwards arrow. But since we're talking about domain, I view it as a leftwards arrow. Does that make sense? Correct. So going this way is negative, going this way is positive, going this way is negative, going this way is positive. But understand that the red ones are for domain, the purple ones are for range. So, all right, let's get back to it. So we all should agree that the domain starts at negative infinity. And how far right does graphy go? Yeah, and this is where we start to realize that maybe it's not as easy as we think. The answer is 2. And so here it goes. I'm going to zoom in a little bit on this for you. And what I want you to see, and I want you to agree, but only when you're ready to agree. Let me zoom out a little bit more. And when you're ready to agree, please agree that this point right here is the furthest rightest point on the graph. And again, don't agree to be polite. Agree when you agree. Now, that point on the graph is covered or associated with what number on the x-axis? Look above that point, and what number do you hit on the x-axis? That's why I put 2 here. The domain is all about the sideways numbers. Now we switch gears. And what's funny about this is that now I go from not caring about the y-axis numbers to not caring about the x-axis numbers. So when we switch to range, what we have to do is basically get those numbers. Can I have that? Or can you just set it over there? Not if you're going to crinkle it. No. I know you didn't mean to, but you have to stop. Thanks, buddy. Um, so at this point, now that I'm about to talk about range, I only want to focus now on the up and down numbers. If you haven't figured this out yet, which it's okay, domain is left and right, right? And range is up and down. So the numbers that I care about change. Domain, I think about sideways numbers. Range, I think about up and down numbers. And so for my range, I'm going to say, how low does graph go? Negative infinity. And this arrow right down here is now viewed as an arrow that points downwards, right? So because the graph is going downwards forever, then I can say that the graph goes as low as negative infinity. How high does graph go? It would not be 7. It would not be 2. Can you not see? Can you see the arrow on that graph? You're not allowed, and this is why we're having this conversation. We got to work all this out of our system. It is not about what you can see with your eyes. Just because you say, well, I can only see the graph making it to 7, you don't have a leg to stand on if that's your case, because this arrow implies that this graph is not going to stop doing what it's doing. It's going to go forever in that upwards direction, meaning that the range makes it all the way to positive infinity. Just because you see it run out of graph to cover doesn't mean it stops. That arrow is a very powerful thing. So the range, basically in plain English, is graphy goes forever down, graphy goes forever up. It's a very lazy, sloppy way of saying the range. Question 3. Um, the closed means the graph gets there. The open circle means it doesn't get there. Let's talk about problem 3. And again, until you understand this, I feel for you because I know how immensely frustrating it is. Whenever you're ready, it'll happen. First off, is this a function? Oh, no, absolutely not. I'm sorry, uh, not trying to be silly when I use these words. How far does graphy go to the left? Yeah, you cannot. I mean, you could try, but you're not allowed to disagree that that line that I just drew is the furthest left point on the graph. You cannot tell me it goes any further left than that. So I can say that the domain begins its journey at -6. Because this line right here, this red line, you have to agree is as far as the graph goes, correct? Do you see how it gets to the line and bounces off right here? Where does that line go through the x-axis? -6.
But does not go this way then? Or on the other graph, it was closest on the right, the furthest to the right. And now that was.
How far right does graphy go? To this wall. And that is a +6. Now, I've done it this way on purpose because I had a student in second hour. Because I'm recording, I'm not going to use his name. But I had a kid earlier who said something, and it was interesting that his approach to this was to put your boundaries down first and worry about the round and square stuff later. So we all need to agree. And I don't want you to leave this room today until you agree that the graph is contained completely in between these two red walls. Like if I can't convince you of that, it's probably time for me to look for other work. Everything in the blue graph exists in between those two walls. And I need some buy-in from you that the wall on the left is named -6, because that's where he goes through, and the wall on the right is named +6. So we all agree. And by the way, the graph can do whatever it wants in between. It could be having some kind of dog and pony. I don't care what it's doing in the middle. What I care about is the confinement of this situation. The graph is confined between the two red walls. Therefore, the domain is defined as leftist point is -6, rightist point is +6. The domain and the range are not about what's happening with the graph. It's about where do they start, stop. Now, does the graph make it to -6? Right here, let me zoom in and I'll highlight. Does this graph right here make it to -6?
Yes.
Yes, it does. People say, well, how do you know that? I say, because I see it. If someone wanted to tell me that it doesn't make it there, they would have put an open circle, one of those hollow circles, a donut. If I saw a donut there and I go, whoa, 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 pump the brakes, someone wanted to tell me that the graph doesn't make it. I see it with my own eyes, that it is reaching a leftness of -6. Because it reaches the leftness of -6, we are going to put a square on the side. The square bracket in math is what we say when it gets there. Does the graph reach the rightness over here of +6?
Yeah.
Then I will again square it off.
So
If I wanted it to be round, just FYI, this is what I would have done. And by the way, I didn't write this problem, the computer did. But if I had wanted it to be a round, then I would have put a circle here like this. Now, if I ask you, does it make it to 6? Your answer is no. I can clearly see that someone went out of their way to put an open circle there to say it doesn't make it. That's what the open circles are for on a graph, is to tell someone, whoa, stop, it doesn't get there.
so would it be round on both sides or just one side?
Square on both sides.
No, but if it has a circle, it doesn't move.
Well, the circle only affects that side. So like if this side were like this, then I would change only this side to round, but the other side would stay square because it's not got the, oh, you see what I'm saying?
Yeah.
Let's talk range now. And I'm going to use my words until you start using them back at me, because I think that this will get a lot easier when you start using the little kitty words. How low does graphy go? -7. You can see with your own eyes that literally the bottom of the graph is right there. You cannot win a fight contrary to that. That is the bottom of this blue graph. Therefore, we can say that the range begins at -7. And again, it can do whatever it wants. It could go boom. But we have to all agree that no matter what it did in the middle, up here is the highest. Up there, where I'm moving my pen, is the top of the top, right? And how high is that? So the range goes from a lowness of -7 to a highness of 3. Does it reach -7? Yes. Does it reach 3? Yes. Okay. Squares if it gets there, rounds if it doesn't. Number 4. Easily one of the most confusing things I will have attempted to explain to you in our first 7 or 8 weeks together. Here it goes. Well, this part's not confusing. Is it a function? Of course, it's a function. Yes. I mean, you can't pass the vertical line test any better than this clown just did. Like, you could slide this line around all day and it's never going to hit that graph twice. So yeah, that's a big time function. Let's talk domain. Again, little kitty words, not to be insulting, but to help your cause. How far left does graphy go? Forever, so it's -infinity. How far right does graphy go? And this isn't one where I need to talk about a lot about little hollow circles and stuff. As I've said, and I'll say it again and again and again, infinities, whether they're negative or positive, always get round. And the reason for that is because round means you didn't get there, and no one can reach infinity. No graph. You could take 1 trillion human lifetimes and that graph is still never going to reach the end of its journey. The concept of infinity is weird. This is the hard part. Range. I don't want to use your name since I'm recording, but you need to wake up. How low does graphy go? How high does graphy go? Yes. So you might remember from yesterday's lesson that if a graph literally never leaves where it starts and stops, then the range is not an interval, but rather a set. The range is one number, -3. What do all of these red points have in common? And try to avoid sarcastic answers like, they're all round or they're all red. I mean, in all seriousness, what does every one of those red points have in common? They all have the same y coordinate. All of their y's are equal to -3. And that's why the range can be summarized as just a number. And we use the curly bracket because it's not an interval, it's a set. It's a set with one number in it. Number 5. Is that a function? Yeah, this is quite literally as not a function as something can be. You can't fail the vertical line test any worse than a vertical line does. So no, it's not a function. What's the domain? Yes. Every point on this graph has an x coordinate of -2. What is the range? It goes down to here. I agree. So it starts its journey at -5. Does it get there?
Yes.
Yes.
And why do we know that? Because the circle's colored in. Good. Huh.
Wait for.
How high does graphy go? Does it get there? Then we square it off. Question 6. Not a function. So I would write not a function or something like no or whatever you want to do, like I said. Here goes. I gotta fix this. I gotta zoom out and zoom back in because it gets all wonky when I mess with it. Oh, it's still wonky. Never mind. I didn't fix it. Domain. How far left does graphy go? The voice of reason. Listen, you cannot overlook this arrow. How do you view that arrow? Do you view that as an upward arrow? It is not right now an upward arrow. I need you to agree with me that that arrow points to the left. Because we're talking about domain, and domain has nothing to do with whether you go up or down. Domain is all about left and right. When someone draws an arrow like this on a board, you have a choice. Olivia might look at that arrow and say, that arrow goes to the left. And Violet might look at that arrow and say, no, you're crazy. That arrow goes up. They're both right, but there's a time and a place for each of those perspectives. When I'm talking about domain, I have to choose the answer that involves left and right. This arrow that I just drew on red right here, I need you to agree with me. Again, not because I'm older than you, that arrow points to the left. For that reason, how far left does graphy go? To negative infinity. The arrow implies it'll never stop. If you spent 1,000,000 consecutive human lifetimes following this graph on its journey through space, it's going to keep going like this. And then 1,000,000 years later, you keep following and it's still going left, not up, left. Because the conversation I'm having with you is not about up and down. It's about left and right. 5 quintillion years later, you're still following that line through the universe out into some distant corner of the universe. Guess what it's still doing? It's still going to the left, which is why the domain says, I'm going to be negative and I'm going to keep going negative infinity. How far right does this graphy go? Let me get back on task here. How far right does graphy go? I'll show you. This, you have to agree. I don't mean to bully you, but you have to agree that where I just drew that little red wall is the furthest rightness that this graph ever achieves. You on board with that? What is the X location where I just drew that wall? Do not say -2 because that is a y-axis number and you do not care about the numbers that I am scribbling out. They are y-axis. They mean nothing when I'm talking about domain. What is the X coordinate of this point right here? It is 0. Domain is all about the x-axis numbers. Now we reset. And now I do care about the numbers on the y-axis, so I want to use my eraser and bring them back to life. What I change now is I get rid of these, because as soon as I start talking about range, I'm no longer interested in left and right. I'm interested now in up and down. So for range, I ask you the question, how low does graphy go?
-6.
To -6. You have to agree that this red line that I'm drawing right now marks the bottoming out of this graph. And it has a depth of -6, but it doesn't get there. So I put a circle, a round bracket. This hollow circle is our indicator. Doesn't get there. How far up does graphy go? to infinity. I now view this arrow as an upwards arrow. A minute and 45 seconds ago, I was sitting here lecturing you about how, no, it doesn't go up, it goes left. But now that I'm talking about range, I view it as an up, not a left. I lose my interest in left and right when I start talking about range. Range is uppy downy. What I know about this is that I could give you 100 of those, and some of you wouldn't click until the 88th one. And that doesn't say anything about you. Some of my best students have struggled with domain and range, while some people have surprised me. People that have struggled with other things get domain and range quick. All I know is we're not going to stop talking about it until I can look at every one of you and you can, with confidence, give me domain, boom, boom, range, boom, boom, like easy. So let's quick talk about this and then that's it. What changes now is that the points aren't connected, right? So it's no longer continuous. Does anyone by chance remember the word I used yesterday? What do we call it when the points are not connected? Excellent work. So what changes when we get to discrete data is that now I don't use an interval. I don't say that X goes from here to here, because that would be an implication that every X in that interval is included. That's not true. I need you again to agree that this point with the arrow pointing at it is the furthest leftist point on this graph. Do you agree? Then the domain starts at -4. Now, as we work our way from left to right, look at red line and watch how he detects points. Do you see how he detected a point here? He will detect his next point here. What's that X coordinate? So then I go -3. And then I move the red line and he sees another point here. What's that X coordinate? -1. Next up, he's going to see a point here. But oddly enough, he sees 2 points. So that's okay. What is the X coordinate of these points? So that concludes the domain. There are no points. If I move that vertical line off to the right, he'll never see any more points. So I seal off the domain. Is this a function?
No.
It is not. I can clearly see it failing the vertical line test. Let's talk about range. So with range now, what I do is I take my point detector 3000, and instead of having it be a vertical detector, I switch it to a horizontal detector, and it starts at the bottom and works its way up. What will be the height of my line when it sees its first point? So -3 is the first element of my range. And I'm using the curly bracket now because I'm putting a countable, distinctly separated set of numbers. So it starts at -3. When will my line, my point-o-matic 3000 see the next one? At 1. How high will I have to go before he sees the next one? 7. And he sees a lot of them at 7, but as you should know by now, points that are horizontally in line, we're not too interested in those. So we would say on this one, no, it is not a function. And then this would be our domain and this would be our range. Got it? All right. That took a little longer than I meant, but I think in the end, hopefully it'll be time well spent. I got a lot of questions today about, oh, you don't want that, about when is it round? When is it square? As those questions arise, I'll unpause this video and just keep adding information to the video so that maybe it would help somebody someday. I don't know, but assignment 12 is here. Violet has kindly offered earlier. She said she wanted to hand these out. So thank you, Violet. You did. Yeah. Do you not remember that? Yeah. Okay. Yeah, I made that up. This is the page I was talking about. A young man during second hour had asked a question, and I can always feel like the feverish sort of stress level go up at this time of year. Domain and range kind of are poopers. And the question just keeps being, I don't know when to do the round. I don't know when to do the square. And so I put this up here kind of as a guide or a cheat sheet. And what I was trying to explain to this guy was that when you see a circle at the end of your graph, if it marks one of your endpoints, like the lowest or the highest or the leftist or the rightest, then you use the round bracket, right? Because the circle implies it doesn't reach. When you see a colored in circle, like a full one like this, and if it's the end, like the leftist, the rightest, the lowest, or the highest, that's when you use the square bracket. And then what I was trying to show with these last things is when you see an arrow, it means the graph goes forever. And how you view that arrow, I might look at Shayla and she might say that arrow goes up. And I might look at Sophia and she might say that arrow goes to the right. They're both correct. I just have to view that arrow dependent upon whether it's domain or range. If I'm doing domain, I view it as a right. If I do range, I view it as an up. But the point I was trying to make when this dude asked about this was that you'll always use an infinity with arrows, and it'll always be a round bracket because infinity cannot be reached. That's why it's round. And so again, here's a purple arrow. And if you surveyed 100 people and said, what direction is that arrow going? A lot of them would say down. But you wouldn't be allowed to tell someone they're wrong if they said, no, it goes to the left. They're both right, right? So I would view it as a leftward arrow if someone were asking me about domain. I would view it as a downward arrow if they were asking me about the range.
What if there's an open and closed circle on the graph?
Then you're going to have different. So let me go back up to problem 1 here to answer your question. So, and I feel good that I'm recording this. I think I resumed this. Yeah, I did. So all this information will be out there for anyone who's not here. So this is great. Let's do this. And again, you'll have lots of time going forward, so don't feel like you have to be in a hurry. Number 1, I'm going to continue. Well, first off, is it a function? No. So let's get that out of the way right now. Let's just right now get just put no, boom, call it good. Now, when I ask you about domain, I need you to get out your Ahern to Kid translator. And when I say what's the domain, I need you to say, how far left does graph E go? I don't think those words are hard to understand. Can you with your pencil tip right now point to the place on this graph that marks the furthest left that the blue line goes? I bet you can. And I bet if you put your pencil down, you're going to put it right down where I just put this red dot. Do you agree? So all you have to tell me is what is the x coordinate of that point. Therefore, your domain starts at -5. Now, I'm going to erase that dot now because I'm not interested anymore. Now, go ahead. It makes it a square because it gets to that point. If I wanted it to not be a square, then I would have put a blocker there. Like I would have done something. I showed you this earlier, but I think you're more prepared now to hear this answer. If I wanted it to be a round bracket, I would have put a blocker here, like a hollow circle, to show you that the graph doesn't actually make it to the wall. Fantastic. You're so welcome. So now we're going to talk about the range. No, we're not. We're going to talk about the other side of the domain. Now take your pencil and put it on the point that you believe to be the furthest right that this graph ever goes. And when you're done, unless you don't understand some basic things about directionality, I'm assuming that your pencil tip is on the point that I'm pointing at with those arrows. And what is the x coordinate of that point? Therefore, your domain ceases at 3. Now, this goes back to Tegan's question. Does this graph actually make it to that point? It doesn't, because someone went out of their way to put the hollow donut on that point. And the hollow donut tells me Graphy tries to get here and he gets infinitely close to here, but he doesn't make it here. And that's why we put a round parenthesis bracket on that end to show he didn't quite make it. With range, I shall now change my perspective. I will completely erase everything I just talked about and start over. The question with range is now, how low does Graphy go? And to answer that question, I need you to go back now and put your pencil on the lowest point on this blue graph. And when you're ready, which I assume you're pointing right now at this point, you're not going to call that point 3 again, because I don't give a rip about his x coordinate. What is the y coordinate of that point? Therefore, the range begins at -6. And why did I put it as a round bracket? Well, because the circle's hollow. That means that it doesn't get there. Again, don't pay any mind to what the graph is doing on its journey. I don't care. Move your pencil tip now and place it on the point that you deem to be the highest point on the blue graph. And man, do I just have to assume that you're pointing at this red dot up here. Is that correct? What is his y coordinate? How high is he? So we put 6 square bracket. Done. And why is it a square bracket? Because it makes it right. The solid circle tells me Graphy made it home. Let's go to number 2. Yeah.
So can you put like at the top, like with the solid circle in the hole?
Right.
Those like brackets.
No,
like
you
what
would
brackets?
put that in your notes. Yeah. So on a quiz, which, would be like next week sometime, you would of course put that on your page of notes. Little things like this are the kinds of things that you would put in your notes, but you have to put them in your notes in such a way that the day you look at them when you're taking a quiz, make sure they make sense just to you, because you're the only one that has to use your notes. Okay? You're so welcome. Let's do problem 2. I don't mean to be doing all your homework with you. I just figured I'd get you jump started here. So first off, is number 2 a function? Nah. Again, this is the definition, the epitome of what it means to not be a function. All right, here we go. This is the hardest part, is these vertical and horizontals. And what's the domain? Take your pencil right now. Oh, what interesting. I should have thought of this years ago. It might not work. Take your pencil right now and put it on the point on the blue line that you deem to be the furthest to the left. Go on.
30.
The thing about this is that Sophia might have put her pencil on this point. Violet might have put her pencil on this point. Dilcia might have put her pencil on this point. Olivia might have put her pencil on this point. Caden might have his pencil on this point. Dave might have his on this point. Cruton might have hers on this. Like, we all might have our pencils on different points. But what is the one thing that all of those points share as a common trait? They all have an x coordinate of 3. Therefore, we will use set notation and say that the domain only consists of one location, 3. This graph never goes to the left. It never goes to the right. It stays. Its entire existence is hinged where x equals 3. That is hard to understand. So if you're having a hard time, that is normal. Now, I'm going to shift my thinking to the easier one. How low does Graphy go? I agree. If I asked you guys to keep, doing the game where you point to what you think is the lowest, if I said point to the lowest point on this graph, every one of you would point to this dot at the bottom, right? And we would all agree that that dot at the bottom has a height, a y coordinate of -5. Would that one be a square or a round? It'll be a square because I can see in the graph that it makes it to the depth of -5 because someone took the time to make that point colored in, which tells the reader of the graph when it's colored in, Graphy made it home. He made it down there. That makes sense? That's why it's square. If I asked you guys all to point to what you deem to be the highest point on this graph, barring some sort of like weird alien invasion that takes over your brain, every one of you would point at that dot right there. What is the height or y coordinate of that dot? Therefore, the range goes continuously from -5 up to 4. Will this bracket be rounded or a hard square bracket? It'll be rounded because someone went out of their way to leave that donut open. And the open dot tells me Graphy didn't quite make it home. He died on the doorstep. Which is, I'm sorry, that was a little bit somber and violent, or that's not the right word. My bad. Let's go to problem 3. Is he a function? You say no, prove it. Why not?
I do.
I'm with you. Just because I'm questioning Casey doesn't mean I disagree. I just like it when kids stand their ground. I agree with you, Casey. It's not a function. Prove it to me. Why not? Correct. Listen, if I make my vertical line my function detector-o-matic 3000, here he is. He's ready to come into battle. Are you ready? Here he is. And I'm going to scan him across this graph. Does he hit the graph twice ever here? Do you see how he's always just riding the line, but the blue line will never make contact with my Scanomatic 3000 more than once. Even on this steep run here, it's still only touching the blue line once. And so at this point, you are correct to say, this is looking pretty good. I think this dude's a function. And then guess what happens? You get right here and watch. Boom. My function detector-o-matic 3000 just blew up and started flashing lights at me because at that moment in time, it hits the graph more than once. And for that reason, you had it, Case. This is not a function. It passes the vertical line test a lot. But listen, if you fail the vertical line test once, game over. All right? What is the domain of this graph? Say it to me in plain English. How far left, how far right? Go. -6 on the left, +6 on the right. Does it make it to the left? Does it make it to -6? Yes, it does. So my domain will have a hard bracket, a square bracket at -6. And does it make it as far right as 6? Yes, it does. So it'll be hard on both sides. Square. Let's talk about the range. With range, I have to change the way I think completely. I give 0, you know what's now, about leftness and rightness. My thinking now is, how low does graphy go? If I said to every one of you, all 10 of you in this room right now, or 11, whatever you are, if I said to every one of you, point right now to the point that you deem to be the lowest, I would be willing to bet that about half of you would point at that red dot, and about half of you would point at that green dot. Who's right? Both of you. We can say, even though it's a tie, that the graph reaches a depth of what? How low does this graph go? That is correct. The graph makes it to -3. And if I said to you now, everyone take your pencil tip and point to what you deem to be the highest point on the blue graph, this one isn't up for debate. If you point to any dot other than the red one, then I'm going to have to question your motives, right? Clearly, that's the apex of the graph. Don't fall for this and think that this dot has anything to do with the range. It happened to be the furthest left, but I give 0 craps about it for the range because it's not the highest point. I want the highest point for the range. And what is the height of that red dot? Does it make it?
Yes.
Therefore, it gets a squared off bracket.
Oh,
You're welcome. Keep asking your questions. And I'm telling you, the questions you have today, you're going to keep asking, and eventually you're going to stop asking them because all these lights are going to start to click on. And when they click, it's going to be like a domino effect. You're going to go quick. Bam, I get it. But you have my sympathies. This is a very, very upper level-y difficult concept. So just keep at it. I'm going to be done working with you for the day because class honestly is almost over. I think we get out at what, 2:48? It's 2:46 and change. So tomorrow plan that we will continue working on this assignment 12, and I might add on another one. I might not. We'll just kind of see how the day goes. But you're in the thick of it now. And if you're walking out of this room today and you feel like you know the whole domain range square round thing, you're doing great. But if you don't, keep your head up, keep your chin up.